Alright, let's talk a little bit about mass, density, and volume, and the relationship between all three of these. And mass, remember, mass is the amount of matter in something. It's what it's made of. It's the stuff that everything is made of. So even air, everything has mass. And mass is equal to volume times density. Okay, so remember this little equation, m equals v times d. And with that also then you can rearrange and manipulate that equation so that you talk about volume. It is equal to the mass of an object divided by its density. And the volume is the amount of space an object takes up. Remember that solids have a distinct amount of volume, where something, a gas, can take up whatever. It's going to fill up the space. It's going to expand to fill up the space that it's in. So something like oxygen does not have a definite volume or a definite, a definite volume or a definite shape. Okay. And then the last thing is density, and it's the amount of matter in a given space. You talk about things like ice is less dense than water, even though they're both H2O. The solid state of water is actually less dense than the liquid state of water, and that's why ice floats. So again, we just manipulated that little equation so that density equals mass divided by volume. Remember our first equation we looked at, mass equals volume times density. If you manipulate that and to get either any one of these different equations. So if you just do out the math, let me get a blank. Okay, so well, here we go. Mass equals, look back at our little, maybe I can get it to cooperate today. Mass equals volume times density. Okay, I'm not cooperating too well. There we go. Mass equals volume times density. Alright, and to manipulate that, so for example, we wanted to figure out what the volume is, we would just multiply. Well, no, let's do this. We're going to divide. We want to find out what volume is. I'm sorry. Multiply or divide both sides by density so that you end up with volume is equal to mass divided by density. Alright? So we have our mass equals volume times density. Okay, and if you wanted to find density, the same thing. You would just divide both sides by volume. So mass divided by volume equals density. Okay? Alright. So what is the difference then? You say, mass and weight. A lot of people say mass is weight. Well, that's not accurate. Weight is actually the measure of the gravitational force on an object. So you take the mass and you combine that with the force of gravity pulling on that object, and that gives you weight. So you're actually measuring the gravitational force on something. So the higher the mass, the higher the weight. The more mass it has, the more force is being pulled upon that object. So there is a very distinct difference between mass and weight. How about area? It's the amount of surface included within a set of boundaries. So it's the area of the table that you're sitting at, the area of an acre of land. Okay, an area is always expressed in a unit squared. So meter squared, centimeter squared. Those are metric units. We talk about, maybe you're building a house and you talk about how many square feet does a house have, right? It's an area, is in meters squared. So remember that key. It's very key when you're talking about these things that you keep your units in mind. And anytime you see, if you saw 1 meter multiplied by 1 meter, you know that the answer is going to equal in meters squared. And that tells you an area. Okay, temperature. Temperature, we always think of, how hot or cold something is. And what temperature actually is measuring is the vibration in those particles. And the hotter something is, the warmer something is, the faster those particles are vibrating. And when you say something is 10 degrees Celsius, you're actually talking about how fast those particles are moving. So the colder it is, the slower those particles are moving. The hotter it is, the higher those, or faster those particles are moving. Okay, so Fahrenheit, we here in the U.S. that's what we talk about, things in Fahrenheit, but the metric we use is Celsius most of the time for our purposes. You're going to be dealing with things in Celsius, and there is a conversion for how to convert from Fahrenheit to Celsius, and we'll talk about that later on. But close enough for our purposes right now today is 32 degrees Fahrenheit is actually 0, so that's freezing. That is where water will freeze at 32 degrees Celsius, or excuse me, 32 degrees Fahrenheit is when water will freeze, or that's 0 Celsius. 212 is when water will boil. And in Celsius, that's going to be 100 degrees Celsius is water boiling. And that's what we base things on, is when water will freeze and when water will boil. And we'll talk about the conversion and how you actually do this very simple equation, little math, and you can convert from Fahrenheit to Celsius. And there you go. There's your conversions. I guess we're going to talk about it right now. Just Fahrenheit. If you're going to go from Fahrenheit, whatever temperature you're starting with, say it's 10 degrees Fahrenheit, you're going to subtract 32 and divide by 5/9, and that's going to give you your Celsius measurement, or your Celsius temperature. And then when you go from Celsius to Fahrenheit, okay, you're going to just flip that equation and take your Celsius and multiply it by 9/5, and add 32, and that's going to give you your Celsius measurement.